Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the today's session, I will discuss the question which was asked in the GATE 2025 engineering science paper from the solid mechanics. A massless cantilever with a tip mass of 10 kg is modeled as an equivalent spring mass system as shown in figure. The length of this particular beam is given as 1 meter and the diameter is given as 20 mm and the Young's modulus of elasticity, which is nothing but 200 gigapascal. The natural frequency of spring mass system you have to calculate, and that frequency you have to put in the unit hertz. The mass is given as 10 kg and the length of beam is 1 meter. 1 meter means 1000 millimeter. The diameter is given as 20 mm and the Young's modulus or modulus of elasticity is given as 200 gigapascal, or I can write 200 into 10 to the power of 3 megapascal or Newton per millimeter square. Okay, so I'm writing all the units in mm only. Now, what is the natural frequency formula? The natural frequency is nothing but root of k by m. Root of k by m. So actually there is a beam, cantilever beam, and there is a mass which is placed over this particular beam and it is modeled in the form of spring mass system. So you have to calculate the natural frequency of this system. So the mass is already given. That means you have to calculate what is the stiffness of this particular beam. The stiffness of beam, how you will calculate? When the point mass is acting at the end of cantilever beam, you know the deflection is nothing but, the deflection is W L cube by 3EI. W L cube by 3EI, where W is the weight of that particular block or the point load. Now from here you can easily write the stiffness of beam is 3EI divided by LQ. Okay, 3EI divided by LQ. That means the stiffness you can easily calculate by using this formula. Once you will plug this value in this one, then you can get the value of omega n. But you have to calculate the natural frequency in hertz. So you know that omega n can also be written as 2 pi into frequency in the hertz. Okay, so you just equate these two part, then you will get the frequency in the hertz, which is nothing but the natural frequency. Okay, so I will write here. So the frequency Fn can be written as 1 by 2 pi square root of kb divided by m. Kb divided by m. So what is the kb value? Kb value you can calculate 3EI divided by L cube. So EI, Young's modulus, is given as 200 into 10 to the power of 3. And what is the value of I? You know that this basically the beam is in the form of circular because the diameter is given. So the diameter is given as 20 mm. So 20 mm, that means what is the moment of inertia? Pi by 64 d to the power of 4. So the diameter value, so I can write the diameter value 0.02 to the power of 4 because it is in the mm. Now divided by L cube. What is the length of this beam? 1000 millimeter. So this will become 1000 to the power of q. Okay, from here once you will solve, the stiffness value you will get as a 4712.389. Now if you put this value in this first equation, then you will get the frequency in the hertz. So 1 by 2 pi square root of 4712.389, and the mass value is also given. The mass of block is 10 kg. Now you can see here. So this value is 10. So once you will solve, the frequency value you will get as 3.455 hertz. 3.455 hertz. So this is the correct answer for this particular question. Okay. Now move to the next question. The question is, consider the two block P of mass is 100 kg. That means the mass of block is 100 kg. Q is the another block having mass is 150 kg, which is resting as shown in figure. The coefficient of friction between these two blocks, which is given as 0.2, assume no friction exists at all the other interfaces. That means here the friction and here the friction you have to neglect. Only the friction which is acting at this contact between these two blocks, which is nothing but P and Q. The minimum force which is required to move block P upward is W. Which one of the following option is closest to the correct magnitude of W? So what you are doing, you are applying some particular force, which is nothing but a W force. So what will be the minimum force value that you have to calculate so that this block will move in the upward direction? How you will solve this problem? First of all, you will draw the free body diagram of the block P and Q. That means what are the forces which is acting over the block P as well as Q. Then either you can use the equilibrium equation, the force is in x direction and y direction 0, or you can use the Lami's theorem also. Okay. So first of all, what are the forces acting on this particular block P? One is the normal reaction. Let us suppose this is N, or I can represent with the N1. And there is a normal force, which is nothing but the contact between the P and Q. Let us suppose this is N2. And this block has a tendency to move in the upward direction, and this surface will move in the outward. So that means the friction force will act in the downward. So let us suppose the friction force is nothing but mu into N2. What will be the resultant of this force? The resultant of this force, let us suppose this is the R. Okay. Now, this resultant of these two forces, which is make an angle of phi from the normal reaction, which is called as the angle of friction. So how you will calculate the angle of friction? By using this particular relation, the tan phi value is mu. So phi value is tan inverse of mu. So phi value is nothing but tan inverse, mu value is 0.2. So that means you will get as a 11.31 degree. Okay, so the angle of friction value you have calculated. Fine. Now, what is this angle? This angle will be 30 degree only. This angle will be 30 degree. Why? Because this inclined plane is making angle of 30 degree from the horizontal. So this is 90 degree. So this value will be, this angle will be 60 degree. This angle is 60 degree. And this normal reaction is perpendicular to this inclined surface. So this is 60, then it should be 30 degree. So the total angle, if I will talk about from the vertical, this resultant is making angle of 41.31. 41.3. Okay. Now, what are the forces acting on this particular P block? So the forces are nothing but, one is the resultant force. One is the resultant force. So let us suppose this is the, I'm just denoting with 1 point. So this is nothing but N1. This is the resultant force, which is R, which is making angle of 41.31 degree. And here will be the weight of the block P, which is nothing but 100 into 9.81, the 100 G value. Okay. Now you can use the Lami's theorem, or you can solve by equating the forces in the x direction as well as y direction. If you take the force of this R component in the x direction, and it will become R sine of 41.31, and this value will be R cos of 41.31. Just use the equation summation of force in x direction 0, summation of force in y direction 0. You will get the value of R as well as N1. But I will solve this problem by using the Lami's theorem, because the Lami's theorem is applicable when the three forces are acting on a body and they are concurrent. Okay, so the Lami's theorem will give you the answer in a quick manner. So what is the Lami's theorem? The R divided by the angle made by the opposite two forces, which is nothing but sine 90, is equal to then 100 into 9.81. That means this force, and the angle made by the opposite two forces, 90 plus 41.31. That means sine 141.31. And N1, you can write down sine 180 minus 41.31. Okay. So from here, only two unknowns are there. If you equate these two, you will get the R value. If you equate these two, then you will get the N1 value. Okay. But I want the value of R only, because if I will apply this resultant force here so that I equate with the W force. Okay, so what is the value of R? R value is nothing but, once you will solve, then you will get 1306 Newton. Okay, so once you know the value of R, so the same resultant force will act in this particular block, which is making angle of 41.31. This angle is 41.31 degree. Okay, so here one force which is acting, which you are applying, that is W. Now you can see here that W is the minimum force which you are applying just to move the block P in the upward direction. Okay, so that you have to find out. And what are the other force will act? One another normal reaction will act here, that is N3, and the weight of this particular block is nothing but the 150 into 9.81. 150 into 9.81, because nothing but 150 into G. Okay, so if you balance the force in the X direction, then you will get the value of W. So take the summation of force in the X direction 0. Okay, let us suppose this is the A free body diagram and this is B. So from free body diagram in B case, so summation of force in X direction means if you resolve this force in the horizontal as well as vertical, so this is the theta angle, which is 41.31. So if you resolve in this direction, then it will become R into sine 41.31 is equal to W only. Why? Because this is the force which is acting here and another force which is nothing but W. So R value you have already calculated. Then from here you will get the W value, which is nothing but 1306 into sine of 41.31. Once you will solve, then you will get 862.31 Newton. So the option A is the correct answer. Now the next question is a simply supported beam with a point load P 150 kilonewton at a distance of L by 3 from the left end as shown in figure. The elastic strain energy of beam is given as this one, where EI is called as a flexural rigidity. The value is already given and the length of beam is 1 meter, the deflection at the loading point. Okay, so this is a simply supported beam. At one end there is a hinge joint, another end there will be a roller joint. At this point you have to calculate the deflection, but the strain energy relation is given. So how you will solve this problem? If the strain energy is given, how you will calculate the deflection value? Just partially differentiating this strain energy with respect to load, that you will get the deflection. Okay, so now the deflection is nothing but, let us suppose the deflection is can be calculated as partially differentiating this strain energy with respect to load. So del by del P, this value is 2 by 243 P square L cube divided by EI. So if you partially differentiate, what the value you will get? So this will become 4, because the P square differentiation with respect to P is 2P. So 2 into 2 is 4. So 4P L cube divided by 243 EI. This is nothing but the deflection. And this is the deflection at the point load P. So all these values are given. Just put in this formula, you will get the answer. So what is the load P value? P value is in kilonewton, so 10 to the power of 3. Length value is given in meter, so I will convert into millimeter, 1000 millimeter cube. So 243, what is the EI value? 16.66 into 10 to the power of 5 Newton per meter square. So here it is meter square, I will convert into millimeter. So 10 to the power of 3 square, then it will become 10 to the power of 6. 10 to the power of 6. Okay. So once you will solve, then you will get the deflection value is 1.48 millimeter. 1.48 millimeter. Okay, thank you so much.